Welcome back, everyone. Ready for another deep dive? You sent in some seriously interesting research about real-time analytics.
It's a fascinating field.
Yeah, it really is.
Yeah.
We want to understand how those systems make decisions so fast, like as the data is coming in.
Right. Like when you see those ride-sharing apps, they show you where the drivers are right that second.
Or how banks can catch fraud in,
Well,
instantly.
exactly. That kind of instant insight is what we're diving into.
So it's more than just having super fast computers, right?
Way more to it than just speed. It's a combo of a few things. A real-time system has four key things you got to look at: latency, throughput, data freshness, and accuracy.
Okay, break that down for me. Latency, that sounds like speed though, right?
You got it. It's how fast a system reacts, basically. Like how quickly it responds to a request. We're talking milliseconds or even faster, like microseconds sometimes.
Wow.
Imagine high-frequency trading. Those systems need to make trades based on market data that's changing constantly. Even a tiny delay can mean they lose money.
So a slow system, that's the kiss of death for a trader.
Pretty much. Then you've got throughput. That's all about capacity. Think of it like how much data can it handle at once?
Uh-huh.
Social media is a good example. Think of how many posts and interactions are happening every single second. It's insane. They need massive throughput to keep up.
So latency's your reaction time. Throughput's how much you can juggle at once. Makes sense. Now, data freshness, does that just mean the data's not like ancient history?
That's a good way to think about it. You got to make sure the data you're using to make decisions is up to the minute.
Right.
Take those ride-sharing apps again. They need real-time data to show you where drivers are right now so you have an accurate ETA.
Like knowing exactly when your food delivery person turns onto your street.
There you go. That's the feeling. And last but not least, you have accuracy. Might seem obvious, but making sure the analysis is actually correct, that's critical.
Right. Especially for stuff like fraud detection or medical diagnoses, a little mistake could have huge consequences.
Exactly.
Okay, so those are our four pillars of real-time analytics: latency, throughput, data freshness, and accuracy. So once you know what kind of performance you need, how do you choose the right system to store all that data?
That's where data stores come in. Your research highlighted three main types: in-memory databases, real-time OLAP, or R2LAP for short, and HTAP data stores, which are a hybrid.
Lots of acronyms there. Let's unpack those. In-memory databases, are we talking literally in the computer's memory?
Yeah, exactly that. They store data in RAM, which is way faster to access than a hard drive.
Right.
So for things where speed is key, like caching or user sessions, they're ideal.
So if I'm logging on to, say, a website, an in-memory database can check my info really fast without waiting for a hard drive.
Exactly. Redis and Memcached are two big names in that space. Redis is great for stuff like tracking e-commerce sessions, and Memcache is popular for, say, managing player data in games.
Gotcha. So in-memory is the speed demon. What about those R2 lab systems? What sets those apart?
RTOLAP, that stands for Real-Time Online Analytical Processing. Those are built for handling huge volumes of data and doing complex queries, making them perfect for applications like dashboards and reporting.
So if I'm like a marketing manager trying to see how an ad campaign is doing in real time, I'd want an RTO-lab system.
Spot on. Two common ones you see are Apache Druid
And ClickHouse. Druid's awesome for marketing analytics, while ClickHouse really shines when you need real-time financial market data.
Very interesting. Now, for HTAP, that's the hybrid one, right? What's the benefit of mixing those two things, the transactions and the analysis?
Well, HTT stands for Hybrid Transactional Analytical Processing, and the advantage is you get the best of both worlds.
Yeah.
You can process transactions like sales while simultaneously analyzing data like sales trends.
Makes sense.
Super valuable for things like retail or logistics.
So a retailer tracking sales in real time and then using that to make decisions about inventory or promotions, that's a perfect use case for HTAP. You got it. TidyD and SingleStore, those are two examples. TidyD works really well for retail, and SingleStore is used a lot in logistics, like managing shipments.
Okay, so we've got our three main data store types. In-memory for pure speed, RTO-lab for the heavy-duty analytics, and HTOPP to do both. But before we get too deep into that, I'm curious, where's all this data even coming from in the first place?
Great question. A lot of it originates from streaming platforms like Apache Kafka.
Kafka, okay.
Think of it as a data highway where producers are constantly sending out data, publishing to topics, and consumers can subscribe to get that data as it arrives.
So it's like a massive digital message board where apps can post and subscribe to different data streams.
That's a great way to think about it. Like a payment gateway processing online transactions might use Kafka to track every transaction as it happens. Then something like a fraud detection system can subscribe to that stream and analyze things in real time.
Makes sense. So the data is streaming in from places like Kafka. We've picked our data store, but is that data ready to be analyzed straight away? Is there any prep work involved?
You're right. Usually there is some pre-processing needed, and that's where ingestion transformations come into play. It's all about cleaning, formatting, and enriching the data before it's stored.
So we're taking raw data and getting it ready for analysis, like prepping ingredients before cooking.
Perfect analogy. Let's say you're getting raw data from sensors at a factory. You might have an ingestion process that normalizes temperature readings, maybe adds geolocation tags, filters out anything invalid.
So we make sure everything's clean and consistent before we put it in our analytical system.
Exactly.
Okay, that makes sense. Now, I've always been a bit fuzzy on the difference between OLTP and OLAP. They both have online in their name, and they sound similar. Can you clarify for me?
Definitely. It's an important distinction. Think of it this way. OLTP, online transactional processing, that's all about everyday transactions, like making a deposit at the bank, buying something online, updating your social media.
Right.
Those systems are optimized for tons of small, fast transactions that need to happen reliably. Then you have OLAP, online analytical processing. That's designed for the complex queries, the deep analysis, often on massive data sets.
Got it.
Like if you're doing sales forecasting or analyzing customer behavior over time, that's where OLS shines.
So OLTP is about the actions, and OLS is about getting the insights.
So that's a great way to put it.
Now, how does the way we store data actually affect performance in these systems?
That's where we get into row-based versus column-based storage.
Okay, what's the difference there?
Think of a spreadsheet. Each row is like a record, each column is a field. Row-based stores data just like that. Works great for OLTP because if you're processing a transaction, you often need all the info from one specific row.
So if I'm depositing a check and the bank needs to update my account, they need everything in that row about my account.
Exactly. Column-based storage, on the other hand, stores data by column. Might sound weird, but it's super efficient for OLTP systems where you're often just looking at specific columns, not whole rows.
So if I want to calculate, say, total sales for the whole year, column-based is faster because it only reads the sales amount column, not all the other data in each row.
You got it. It's like if a library was organized by subject instead of by author. If you only need history books, you don't need to go through all the fiction.
Makes total sense. We talked about throughput earlier, how real-time systems need to handle a ton of data. But what about queries? How do we make sure those get processed quickly, especially if there are a lot of people asking questions at the same time?
That's where queries per second, or QPS, becomes a big deal. It measures how many queries a system can deal with at the same time. Crucial for things like customer support systems or social media where you have tons of users all at once.
So if thousands of people are trying to log onto my site at the same time, I need a high QPS to handle that traffic.
Exactly. And indexing is one of the best ways to boost that and make queries run faster. Think of indexes like a table of contents in a book.
Oh, right. So I don't have to read the whole book to find what I'm looking for.
Exactly. You have different types of indexes for different needs. Bitmap indexes are good for filtering based on simple things like finding customers in a specific city. Sorted indexes are great for range queries, like finding transactions within a certain date range. And inverted indexes are essential for text searches, finding all products with a certain keyword.
So it's all about choosing the right tool for the job.
Exactly. A well-designed indexing strategy makes a huge difference. Like a retail analytics system might use bitmap indexes to filter transactions by payment type, and inverted indexes for when someone searches for a product.
Okay, that makes sense. But what about really complex queries, the ones that need to aggregate data across multiple dimensions? Are there special indexing tricks for that?
There sure are. That's where star tree indexes come in. They pre-aggregate data across multiple fields, so they're incredibly efficient when you're dealing with lots of aggregations.
So instead of calculating total sales by region, device type, and campaign every single time, a star tree index has that answer ready to go.
Exactly. Think of it like having a pre-calculated summary table that's always up to date. This makes answering complex questions super fast. Like an ad analytics system might use this to instantly tell you how many ad impressions you had by region, device type, and campaign.
That's impressive. Okay, so we've analyzed all this data and we have all these insights, but how do those results actually get to the people who need them? Do we email them a spreadsheet?
Not quite. There are two main ways to deliver analytical results. Synchronous queries, those are also called pull queries, and asynchronous or push queries.
Okay, what's the difference between pushing and pulling data?
Think of it this way. With synchronous queries, the client, like a business intelligence tool or something, asks for specific data, and the system responds. It's a request and then a response, kind of like ordering something online and waiting for it to arrive.
Okay,
Like if a business intelligence tool asks for sales trends for the last quarter, the system goes and gets that specific data.
so the client asks and then waits for the answer. What about asynchronous?
With asynchronous queries, the data is delivered proactively without the client having to ask. It's a publish-subscribe model, like getting a notification on your phone. Like a livestock ticker might use something called WebSockets to constantly send price updates to anyone who's subscribed.
So push queries are like getting live updates, and pull queries are like asking for information when you need it.
Yeah.
Got it. But which one's better, pushing or pulling?
It depends on what you're trying to do. Push queries are usually faster because the data is sent as soon as it's available, but you don't get to choose exactly what data you get.
So it's a trade-off between speed and control.
Yeah, exactly. Pull queries are more flexible. You can ask for exactly what you need, but they can be a bit slower because you have to wait for the response.
So is there a way to get the best of both worlds?
A lot of systems actually use a hybrid approach, combining both push and pull. Like a sports analytics platform might push live scores and key events to users in real time, but also let them pull up detailed stats or historical data if they want.
That's clever. We've covered a lot today, from what makes a system real-time to the different ways to store and deliver insights. It's clear why you wanted to deep dive into this.
Absolutely. This is a good point to take a break, though. We've got a solid foundation. When we come back, we can explore some of the challenges that come with building these real-time systems.
Sounds good to me. We'll be right back.
Welcome back. I'm excited to keep digging into this.
Me too.
Yeah.
We've laid out the basics, but I'm sure there's a lot more to it. Building these systems has to have some serious challenges.
Oh, you're absolutely right. Real-time analytics can get really complex. One of the biggest things you run into is just managing the sheer amount of data and how fast it comes in.
Right. It's not just big data, it's how fast it gets big.
Exactly. It's not just about having a lot of data. It's the speed at which it arrives that really makes things tricky.
Like trying to drink from a fire hose, as they say.
That's a perfect analogy. So you need a system that can grow and adapt as the data volume and velocity increase. You might need to add more servers, spread the data out, or even use cloud computing to scale up on demand.
So you're not just picking tech for today's needs, you have to think about tomorrow's too, make sure it can handle the growth.
Exactly. And it's not just about quantity. Data quality matters too. Remember those ingestion transformations we talked about? Those are crucial for making sure the data going into your analytics system is accurate and reliable. If you start with bad data, you're going to end up with bad insights.
Garbage in, garbage out, right?
Exactly. But even with clean data, you can still have errors or weird things happen. How do you deal with that in real time when you don't have time to go back and fix stuff?
Yeah, that's a good point.
That's where really good monitoring and alerting systems come in. You need to constantly watch those data streams and have something that alerts you instantly if there's an issue, like unexpected spikes or missing values.
Like a team of digital detectives scanning for any sign of trouble.
Love that. And when those detectives find something, you need to be able to react fast. That could mean fixing data errors, adjusting how the data's coming in, or even scaling up your system if there's a sudden surge.
Right, so you have to be ready for anything. What other challenges pop up a lot with real-time analytics?
Complexity is a big one. You often have lots of different technologies involved, different data sources, different processing steps. That can make it tough to design, build, and keep everything running smoothly.
It's like trying to conduct an orchestra with musicians from different countries, each playing different instruments, and expecting them to sound good together.
That's a great image. So yeah, you need really careful planning and a clear architecture. You got to understand exactly what you need, where your data is coming from, how you need to process it, and how you're going to deliver the results. Picking technologies that work well together and actually help you reach your goals is critical.
So it's not just about having the coolest, newest tools, it's about making sure they all fit together.
Absolutely. And of course, we can't forget security. Real-time analytics often deals with sensitive data, so security has to be a top priority from the very beginning.
Right, you don't want anyone getting access to customer data or confidential business information.
Exactly. So you need a layered approach. You secure the data sources, the pipelines, the data stores, how the results are delivered, everything.
Makes sense.
You might use encryption to protect data in transit and at rest, have strong authentication and authorization, and make sure you're auditing everything to see who's accessing what and catch any potential breaches.
So it's like a full court press on security, protecting the data every step of the way.
Exactly. And finally, I want to emphasize the importance of iteration. Building these systems is rarely a straight line from start to finish. It's a continuous process of learning, adapting, and making things better.
So you have to be flexible, willing to change course if you need to.
Exactly. Start small, test things out, see what works, get feedback, and keep refining. Don't be afraid to try new technologies or question your initial assumptions.
That's great advice. Speaking of learning from what's out there, you found some really interesting examples of how real-time analytics is being used in different industries. Can we dive into some of those?
Absolutely. Let's see how this technology is actually being applied.
Okay, let's start with finance. Given how fast things move in the markets, I imagine real-time analytics is playing a big role there.
It's huge in finance. It's changing the game in algorithmic trading, risk management, fraud detection, customer service, you name it.
Let's break those down. How is real-time analytics changing things in each of those areas?
Let's start with algorithmic trading, where computers are using sophisticated algorithms to analyze market data and execute trades at lightning speed.
Wow.
We're talking milliseconds, sometimes even microseconds, to take advantage of tiny price differences that might only exist for a fraction of a second.
So these algorithms are making split-second decisions based on real-time market data to grab those tiny opportunities.
Exactly. They need real-time data feeds, market depth information, historical data, all of it to figure out which trades are potentially profitable. If they're even a few milliseconds behind, they could miss out.
It's like a high-stakes race where every millisecond counts. Now, what about risk management? How does real-time analytics help financial institutions handle risk?
Financial institutions are constantly dealing with all sorts of risks. Market volatility, credit risk, operational risk, you name it. Real-time analytics helps them identify, assess, and mitigate those risks much more effectively.
So they're using real-time data to keep an eye on market conditions, figure out how creditworthy someone is, spot anything unusual, and make decisions to minimize potential losses.
Exactly. They can adjust their portfolios, their strategies, how much risk they're taking, all in real time to respond to how the market's doing and protect their assets.
It's like having a finger on the pulse of the market, so they can react instantly to anything unexpected.
Exactly. Now let's talk about fraud detection. As fraudsters get more sophisticated, financial institutions need to keep up to protect their customers. That's where real-time analytics comes in.
Fraud can happen anytime, anywhere, so real-time detection seems critical.
You got it. They're using real-time analytics to analyze transaction patterns, spot anything unusual, and flag suspicious activity as it happens.
Okay.
They use machine learning to learn from past fraud cases and find new patterns as they emerge.
So if my spending suddenly changes, like if I start making huge purchases in another country, the system might pick up on that.
That's right. They're looking for things that are different from your normal spending habits or anything else that might be a sign of fraud.
Interesting.
The faster they can detect and stop those transactions, the less money their customers lose and the less risks they take on themselves.
It's like having a watchful guardian constantly checking for any sign of trouble. Okay, what about customer service? Can real-time analytics improve that too?
Absolutely. Financial institutions are using it to personalize interactions, offer help before you even ask, and overall just make customers happier.
So I call my bank's customer service line. How would real-time analytics make that experience better?
Well, by looking at real-time data, the representative could instantly see that you're a valuable customer, see your recent transactions and account activity, and even predict what you might need help with based on your past interactions.
So they could tailor the whole interaction to me, offer relevant solutions, maybe even avoid those annoying transfers to different departments?
Exactly. They could even reach out to you proactively with helpful tips, reminders, or even special offers that are relevant to your situation.
It's like having a personal financial assistant who knows exactly what I need. Okay, so we've seen how real-time analytics is shaking things up in finance. But it's not just about money, right? What other industries are jumping on board?
You're right. It's not just finance. It's making waves everywhere. Let's move on to e-commerce.
E-commerce seems like a perfect fit. Personalized recommendations, dynamic pricing, fraud prevention, all of that feels like it could be powered by real-time analytics.
You nailed it. E-commerce companies are using it to personalize the shopping experience, optimize pricing and inventory, and yes, definitely to prevent fraud.
So they're using real-time data to make every click, every search, every purchase as smooth as possible.
Precisely. They might analyze your browsing history, what you've bought before, even where you are right now, to suggest things you might like. They might also change prices based on demand, what their competitors are doing, or even your own purchasing habits.
So it's all about creating a more personalized, engaging experience for each shopper. What about fraud prevention in e-commerce? How does that work?
Online fraud is a huge problem for e-commerce companies, so real-time analytics is a powerful tool to fight back.
Okay.
They use machine learning to analyze transactions, find anything suspicious, and flag orders that might be fraudulent before they even ship anything out.
So if someone tries to buy a bunch of expensive stuff using a stolen card and a fake address, the system can catch them.
You got it. They're looking for red flags like inconsistencies in addresses, lots of orders from the same IP address, attempts to use stolen cards, all of that. By detecting and stopping these things early, they save themselves and their customers a lot of headaches.
It's like a constant battle against the fraudsters. And real-time analytics gives e-commerce companies a real edge. Okay, we've got finance and e-commerce covered. Where else is this technology making a difference?
Let's talk about healthcare.
Healthcare. That's an area where real-time analytics could really make a huge impact. Faster diagnoses, more personalized treatments, maybe even preventing outbreaks.
Exactly. It's being used for all sorts of things in healthcare, from keeping an eye on patients in critical care to tracking how diseases spread.
Let's start with critical care. How is real-time analytics helping doctors and nurses in intensive care units?
Imagine a patient hooked up to all sorts of sensors, monitoring things like their heart rate, blood pressure, oxygen levels, all of that. All that data is flowing into a system that's constantly analyzing it, looking for any signs of trouble.
So it's like having a superpowered medical assistant watching over the patient 24/7 and alerting the team if anything goes wrong.
That's it. The system can spot tiny changes that a human might miss, which lets doctors intervene early and potentially save lives.
That's incredible. What about tracking infectious diseases? How does real-time analytics help with that?
Imagine a new virus spreading really quickly. Health officials need to understand how it's moving, who's most vulnerable, and how to stop it.
Yeah, that sounds all too familiar after the past few years.
Right. Real-time analytics can be a lifesaver in these situations. By looking at data from all kinds of places like hospital admissions, lab tests, even social media posts and search engine queries, they can track how the virus is spreading in real time.
So they're using data to paint a picture of what's happening right now, which helps them make decisions about testing, treatment, containment.
Exactly. They can identify hotspots, predict where it might spread next, and focus their resources. They can even monitor what people are saying and address misinformation, which is crucial in a public health crisis.
That's really powerful stuff. Okay, we've done finance, e-commerce, and healthcare. I'm guessing there are tons of other industries where this is making a difference.
Oh, absolutely. We could talk about transportation, manufacturing, energy, government, the list goes on.
Let's pick one more. How about transportation? I'm curious about how real-time analytics is being used for things like traffic, public transport, and even self-driving cars.
Transportation is a great example. It's playing a key role in making traffic flow better, improving public transportation, and yes, even in developing those self-driving cars.
Okay, let's start with traffic. As someone who lives in the city with a lot of traffic, I'm definitely interested in this.
Imagine a city with sensors everywhere, in the roads, traffic lights, even in cars.
Okay.
Those sensors are constantly sending data about traffic volume, speed, how congested things are.
So they're creating a real-time map of how traffic is moving through the city.
Exactly. And that data goes into a system that uses it to do things like adjust traffic light timing, change speed limits, and even suggest different routes to drivers.
It's like having a super smart traffic conductor keeping everything flowing smoothly.
Perfect analogy. And it's not just about cars. Real-time analytics can help with public transport too. Imagine buses and trains with GPS trackers sending their location constantly.
So I could open an app and see exactly where my bus is and when it'll arrive.
Exactly. No more wondering if you missed your bus or waiting around clueless. You could even get real-time updates about delays, cancellations, or other routes.
That would be amazing. What about self-driving cars? How does real-time analytics fit into that?
Self-driving cars need real-time analytics to understand their surroundings, make decisions, and drive safely. They have all sorts of sensors, cameras, LiDAR, constantly gathering data about everything around them.
So they're basically building a 3D model of the world in real time.
That's it. And all that data is going into a powerful computer in the car, using machine learning to figure out what those objects are, where they're going, and how the car should move.
So it's making split-second decisions to avoid crashes, follow the rules, and get people where they need to go safely.
Exactly. It's a really complex task, but real-time analytics makes it possible. And as this technology gets even better, we can expect even more amazing applications of real-time analytics in transportation.
It's incredible to see how it's changing the future of how we get around. We've covered a lot today, from the technical challenges to the real-world examples. But before we wrap up, I want to go back to something you mentioned earlier about the importance of iterating and experimenting. Could you talk more about that?
Sure. Building real-time analytics systems isn't like checking things off a list. It's a constant journey of figuring things out, adjusting, and making improvements. You'll run into unexpected problems, learn things as you go, and have to adapt.
So you have to be okay with the unknown and be willing to change directions if you need to.
That's it. The key is to start small, test your ideas, get feedback, and keep making things better. Don't be afraid to try different technologies or challenge what you thought you knew.
That's great advice. And it feels like it applies to more than just building these systems. It's a good approach to anything new and innovative.
Absolutely. In a world that's constantly changing, being able to adapt, learn, and evolve is essential.
Well said. We've given our listeners a lot to think about today. But before we go, I have to ask about the future of real-time analytics. What exciting developments are coming down the road?
Great question. I think we're just scratching the surface of what's possible.
Yeah.
As we get more and more data and computers get even more powerful, we're going to see even more sophisticated and impactful applications.
What kinds of applications?
Imagine real-time analytics being used to personalize education, make energy use more efficient, predict natural disasters, even create cities that adapt to people's needs in real time.
Wow, those are some big ideas. It sounds like we're on the edge of a real-time revolution that could change everything.
It really does feel that way. It's an exciting time to be in this field, and I'm eager to see what happens next.
Me too. Okay, I think we've covered an incredible amount today. We've gone through the technical details, the real-world examples, and even gotten a glimpse into the future.
It's been a great conversation.
I hope our listeners are feeling inspired to explore this fascinating field even more. Welcome back. We've explored the technical side and seen how real-time analytics is being used out in the world. Now I want to talk about the bigger picture. What happens when we live in a world where more and more decisions are made in real time based on all this data that's constantly coming in?
That's the big question, isn't it? We've talked about the what and the how, but the why and the so what are just as important. What does this shift to real-time decision-making actually mean for people, for organizations, for society as a whole?
Okay, I like that. We're not just geeking out about tech anymore. We're talking how this tech changes how we think and act.
Exactly. In the past, decisions were often made based on data that was already old, gut feelings, or sometimes just plain guesswork.
Right.
Real-time analytics lets us decide based on what's happening right now. It's a whole new level of precision and responsiveness.
It's like having a sixth sense, knowing what's going on in the present and making decisions based on that real-time understanding.
That's a great way to put it. But just like any powerful tool, we have to use it responsibly.
Right.
This real-time revolution, it comes with its own challenges and potential downsides. We can't ignore those.
Let's talk about the potential downsides. What are some of the things we need to be careful of as we rely more and more on this real-time data?
One thing is data overload.
Okay.
We're creating more data than ever before, and trying to find the meaningful stuff in all of that can be overwhelming.
Yeah.
We have to be careful not to get lost in the sheer amount of data and lose sight of what's important.
It's like being in a giant library with millions of books, but there's no system to help you find what you're looking for.
Perfect analogy. We need good strategies to filter out the noise, figure out which signals are important, and focus on the insights that really matter. It's not just about having data, it's about having the right data.
And knowing what to do with it.
Exactly. Another potential problem is algorithmic bias.
Okay.
A lot of these systems rely on machine learning, and those algorithms can pick up biases from the data they learn from.
So if the data already has societal biases baked in, those biases get amplified by the algorithms.
That's right. And that can lead to unfair or discriminatory decisions. We need to be aware of this and try to fix it.
So how do you do that?
Well, we can use more diverse data sets, really scrutinize what the algorithms are doing to see if there's any bias, and maybe even have humans involved in the process to make sure things are fair.
So it's not just about letting the algorithms run free, you have to keep an eye on them.
Exactly. And of course, we can't forget about privacy.
Right.
Real-time analytics often uses personal data, so there are big privacy questions we need to address.
It's a tough balance, using data for good while respecting people's privacy. How do we get that balance right?
Transparency and consent are key. We have to be upfront with people about how their data is being collected, used, and protected. Get their consent. And we need really strong security to prevent anyone from accessing or misusing that data.
So it's about being responsible with that data.
Exactly. Another concern, and people don't always think about this, is that real-time analytics can create this feeling of urgency, like you have to react to everything right away.
Right.
When you're constantly getting bombarded with data and insights, it's tempting to make quick decisions without thinking about the long-term consequences.
It's like feeling like you have to check your phone for notifications all the time. Like you have to respond to every message right this second, even if you're in the middle of something important.
Exactly. We have to find ways to manage this constant flow of information and not let it push us into making rash decisions.
So finding that middle ground between being responsive and avoiding knee-jerk reactions.
Exactly. It's about using real-time analytics as a tool to help us make better decisions, not to let it take over.
So we don't want the technology to be in charge. We want it to help us.
That's it. In the end, real-time analytics is a powerful tool, and like any tool, it can be used for good or for bad. It's up to us to make sure we're using it wisely, ethically, and in a way that benefits everyone.
I love that. We've really gone deep on this topic. The technical stuff, the real-world examples, and now these broader questions about how it affects society. It's clear that real-time analytics isn't just a fad. It's changing the world in a major way.
I completely agree. It's an exciting field with so much potential to solve problems, make our lives better, and create a more informed and responsive world.
And as always, we encourage our listeners to stay curious, keep exploring, and think critically about the role technology plays in their lives and in the world. Until next time.